Hello! In this video I'm going to discuss new inference rules for use with conjunction, and they're going to be pretty straightforward. So, remember that this wedge is the conjunction symbol, that sentence formed with it has a sentence on each side of the symbol, and we call the whole sentence a conjunction. And we call each of the components, each of the parts, a conjunct. So P is a conjunct of P and Q is a conjunct of P and Q. So, simplification in English, this is the inference that we saw in the previous video. The closest women's bathroom is in corridor T, and the closest men's bathroom is in corridor U. What can you infer from this? Well, among other things, you can infer the closest men's bathroom is in corridor U, and this inference is a valid inference no matter what. If the premises are true, so is the conclusion, and we're going to now capture this in our logical language. So, this is straightforward. If you have a conjunction of P and Q, you can infer P. We call this rule simplification, and you can write S. And if you want to tell the program you want the left conjunct, you can write we call that simplification left, and you can write SL. If you have the conjunction P and Q, you can also infer Q, and we call this also simplification, and this rule in particular is called simplification right. So so this is an inference rule like DN, where it has only one premise, not like MP and MT, where you're combining two lines. If you apply simplification to a conjunction and you just write S, it will ask you which do you want. If you write SL or SR, you can tell it, then you're telling it, I want the P or the Q. So, like double negation, we have double negation elimination, where we go from a premise with double negations to a premise without. So simplification is like that. We go from a premise, we get rid of a conjunction, moving from the premise to the conclusion. The conclusion has one less conjunction than the premise does. Double negation introduction lets us introduce a double negation, and similarly, we have a rule that lets us introduce a conjunction. So if you have separately the sentences P and then on another line Q, you can infer the conjunction of them, P and Q. We call this rule adjunction, and the abbreviation is ADJ. And this, like modus ponens, is a two-premise rule. You apply it to both P and Q, so you have to put two line numbers before it when you write down ADJ. So we now have a whole bunch of rules. We have our old rules, modus ponens and modus tollens, and double negation introduction and elimination. And now we have the AND rule. So we have adjunction, which lets us introduce conjunctions, and we have simplification, which lets us eliminate conjunctions. Eliminate, the initial line is not gone. You can apply simplification to a conjunction repeatedly. Elimination in the sense that the conclusion of the inference rule doesn't have the conjunction that the premise does. It has one less conjunction. But the line is still there, and you can apply all sorts of inference rules to it. So you're not eliminating the line, you're just removing the conjunction in your new line. So our strategy remains basically the same, or the sort of procedure. The first thing we do is we introduce a show line, then we enter the premises, and then we apply our inference rules, MP, MT, but then we also have our new rules, simplification and adjunction, as well as double negation. So we just do this repeatedly using our new line. So our derivations will begin to get a little bit longer, and so we'll have to search through them a little bit to look for the right inference rule applications. And one thing we still want to be doing is looking for conditionals and thinking, what do I need for MP and MT? Simplification is pretty obvious to use. Adjunction is a little bit more open-ended. Simplification, you have the conjunction, you apply simplification to it 2 times, and you have 2 new sentences, and that's it. You've taken care of the conjunction. ADJ is like double negation introduction. You could apply it as much as you wanted, so you have to think a little bit more about how do I want to apply it. And then again, we still have to look for antecedents and negated consequence to apply MP and MT. And eventually you'll get to the conclusion of the derivation, and you'll box and cancel with direct derivation. So in another video in this unit, I'm going to illustrate the use of these new rules and how they interact with our old rules in some examples. So I will see you there, or in the other videos in this unit about symbolization with conjunction.